Now that we've talked about the basic reactions that occur in aqueous solutions, now we can turn our attention back to stoichiometry and figure out how we can express a concentration of an aqueous solution. So the last part of chapter 5 in our textbook discusses how solutions are connected to stoichiometry. Okay, so the way that we define concentration in terms of a solution, we define concentration as the amount of solute, so the stuff that we're dissolving into the solution, the concentration is the amount of solute in the solvent. Okay, so how do we calculate this? How do we define this concentration? Well, in chemistry, we have a unit for that, and that unit is called molarity, which we represent with a capital M. And the way that we calculate molarity is going to be the moles of your solute divided by liter of solution. So when we calculate molarity, the units will be moles per liter, or we could represent this with a capital M. So this is very, very, very important. This M has to be capitalized. If it's lowercase, that indicates a completely different concentration system called molality. So it's got to be if we're talking about molarity, which is the one that's most commonly used, you must use a capital M. Or, to be clear, just use moles per liter, and you're good. Okay, so the way that we would read this, let's say you had a 1.27 moles of sodium chloride, you dissolve it in a liter of water. The way that we would express this written would be 1.27 capital M. We would read that as 1.27 molar solution of sodium chloride. Okay, now what does it mean if we had like a 1 molar solution of something? So like what if you had 1 mole of barium nitrate and then you add that to water? Okay, so what that equation would look like if you had barium nitrate, okay, and you add that, you dissolve that in water, you know that this is going to dissociate because this is an ionic compound, and you get barium 2+ ions, and then you get nitrate ion. Okay, now the only difference is you have 2 moles of nitrate ion, because that's, you had 2, that's, you had the subscript 2, so that means you've got 2 moles of that. Okay, so if you've got 1 mole of barium nitrate, you dissolve in 1 liter of water, that's going to give you a 1 molar concentration of barium nitrate. Now, in terms of the ions, however, because they dissociate, you're going to have a 1 molar concentration of barium nitrate, but when it comes to the nitrate ion, because you have 2 moles of that in a balanced chemical equation, that concentration will be 2 molar. Okay, now how do we actually prepare one of these things? We actually have to use a special piece of glassware called a volumetric flask. So the way this works is that here you've got your volumetric flask. If you zoom in on this image a little bit more, you can see that it's set at 250 milliliters. So the first step is that we pour our solute, and that's what we're looking at here. We pour our solute, which is a solid, into the volumetric flask, and then we add enough water that we can start moving it around. We start dissolving it, okay? Once we start dissolving it and we try to get as much of it dissolved as possible, then we can tap this off. There's usually it's a little difficult to see in this photo, but there is a glass etching, and it's probably right at that line. So what you want to do is get that meniscus right to that line as much as possible. Once you get the meniscus touching that etched line, that indicates that you have exactly 250 milliliters of solution. Okay, so that's how we would physically make the solution. Now, how do we actually calculate that? Let's try this out. So here's our problem. What is the molarity of an 85 milliliter ethanol solution that contains 1.77 grams of ethanol? Okay, so let's try this out. So we need to convert, because we're told we've got grams of ethanol. In order to use molarity, again, molarity is moles per liter, we need to know how many moles of ethanol we have. So let's start with that. Let's convert from grams to moles. So you have 1.77 grams of ethanol, which I'm going to shorthand as ETOH. Okay. Divided by, and I'm going to put that over 1 so that way we can keep things neat and tidy. The next step is that we convert this to grams to moles. So it's 1 mole of ethanol, ETOH, over the molar mass, which is 46.07 grams of ethanol. Okay, so grams of ethanol cancel out. We're in moles of ethanol. So we have part of the definition done. We've got the moles. Now, to calculate molarity using dimensional analysis, I need to have another fraction here. But because liters have to be on the bottom, instead of writing the fraction this way, where as the first one, where you have the grams on top over 1, that placeholder 1 has to be on the top now, because on the bottom, that's where we're going to put our volume. So we're told you have an 85 milliliter solution. So that's where I'm going to put our volume, 85.0 ml. Okay. Now, the only problem with that is now we have to convert from milliliters to liters. So for every 1 liter, there's got to be 1,000 milliliters. So that way, milliliters cancels out. Now, look at what happens to the units. What are we left with? Well, notice you've got moles of ethanol on the top. You've got liter on the bottom. So there you go. You got moles per liter. By definition, that's molarity. So math-wise, we're looking at 1.77 times 1,000 divided by the product of 46.07 times 85. So that number that I got was 0.452 molar. And so that's how you would express that answer. Let's try another one. All right, so instead of calculating the molarity, what if we had to work with molarity and find out some more information? So here's our problem. What volume in milliliters of a 0.315 molar sodium hydroxide solution contains 6.22 grams of NaOH? All right, so this one, it's a little bit different because we're looking for volume in this time. We've got the molarity, so we're gonna have to manipulate this a little bit in order to solve for volume. Okay, so think of it this way. This time around, we're using the molarity as a conversion factor. All right, so let's try this out. We'll start, we know that we've got 6.22 grams of sodium hydroxide, so let's start there. So I'm going to start with my fraction, 6.22 grams of NaOH over 1, because we're going to keep things neat and tidy. We need to convert this from grams to moles, because everything's in moles. So for every 1 mole of sodium hydroxide, we're going to have to calculate that molar mass. That molar mass comes out to be 40 grams even. Okay, so that way, grams cancel out with grams, we're in moles. Now, we need to get to volumes. And so we're going to use this molarity as a conversion factor. So the way we're going to write this is we're going to say 0.315 moles of NaOH over 1 liter. We could also write it as 1 liter over 0.315 moles. Okay, and actually this is the way that we're going to have to write this, because that way we have liters on top and the moles is going to cancel out with moles in the last fraction. So let's do it that way. So I'm going to say 1 liter over 0.315 moles of NaOH. Okay, so that way moles cancel out and we're left with liters. That's the unit that we need. Okay. All right, and so we need to solve. Well, wait, I almost jumped ahead. The problem's actually telling us something else. We need to know the volume in milliliters. So we actually have one more step that we got to take care of. So we need to convert from liters to milliliters. So for every 1 liter, there's 1,000 milliliters. Now we can solve. Okay, so this is going to be 6.22 times 1,000 divided by the product of 40 times 0.315. And so that number is going to be 494 milliliters.